Good morning. We're here recording live from
And then
106, my room.
All right, today's podcast is how matter is classified. Excuse you, Keisha.
I know, sorry. I'm a brick. House. Dum, 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 dum. And next, maybe? Hey-o. Okay.
So first slide we have is just kind of an introduction on matter. Matter is everything around you, and everything around you is made up of atoms. And currently there are over 110 different kind of atoms. At this point, they're starting to kind of make them in the lab, so they're not considered almost natural. But there's 110 different kind of atoms that make up everything around you, from the air you breathe, to the desk you're sitting at, to the food you eat. Right, Keish?
Right. So what you're saying is, matter matters.
Matter matters, for sure.
That was a Bill Nye quote.
Yeah. All right, there's going to be different kinds of matter. First one is pure substances. There's two kinds of them. There's elements and there's compounds. Okay, like I just said, there's 110 elements, and that's like the purest form of material you can get, of matter you can get. Okay. Elements are going to only have one type of atom. This is the periodic table. I don't know if you can see it behind us.
You keep going. I got a helpful hint for us, or helpful tool.
All right. So elements are going to contain only one kind of atom. Things like neon. We have on there argon, xenon, helium. Those are all different kinds of elements. Okay. There's about 110 of them. And each element has a symbol. It's usually one letter or two letters long. The first one capitalized, the second one lowercase.
I am back with toys.
Oh, she's back with them.
I made this. It's a mobile. You know, like when you're a little kid. This is probably when I would have hanging over my bed. So, example, element. It only has one thing.
One type of atom. And this
Compound has two. Well, technically it was two at one point. It had other stuff glued here, but perhaps it's a couple years old.
fell apart.
But you can see two different types of atoms. One is clear, one is red.
Okay. Well, we'll
Okay.
get to compounds in a second, but we're still on atoms.
Sorry.
Sometimes you'll have a couple atoms that exist in nature, but they're stuck to each other. So we call them molecules. Some examples we have down on the bottom are going to be hydrogen, nitrogen, and oxygen.
Those would be also called diatomic,
Yeah.
which you'll learn later. Di meaning...
I actually think it's the next slide.
Oh!
These guys right here, this is all of your elements, the 110 we talked about 110. There's going to be 7 of them that show up in nature, stuck to each other, combined to each other. So they exist in like a 2 form. So it'd be like H2 because there's 2 hydrogens, or N2 because there's 2 nitrogens. Lucky for you.
And most of them are normally gases, correct?
Yeah.
Except for that little guy, BR and I. Get to class!
All right. Lucky for you, there's 7 of them, and it makes this number 7 right here. But that's only 6. See, 1, 2, 3, 4, 5, 6. But then also hydrogen counts too. And these guys are called diatomic, di meaning 2, atomic meaning atom, 2 atoms.
Di you should remember from FAS
Yeah.
in your prefixes, suffixes, and roots.
So these guys would be, if we wrote them when they're by themselves, it'd be H2, this would be N2, O2, F2, Cl2, Br2, and I2. Diatomics. Easy enough. There's only 7 out of the 110. Sometimes you'll get these things called allotropes, which are molecules that are the same element, but they act differently. The example we have here is O2. What is O2 famous for? Speech.
Breathing.
Without O2, after about 5 to 10 minutes, your body functions would like cease to exist. So, or start breaking down at least. So here we have O2 that's essential for life. This is ozone gas right here. Okay, very important to the Earth's atmosphere, but it's also poisonous, and it actually has an odor.
Ooh.
I think it's yellowish too, if I remember right. I think it's yellow. Anyway, so this one, O2, is essential for life. This one can hurt you.
Dun dun dun.
Dun dun dun. This one's 2 atoms stuck together. This one's 3 atoms bonded together. All right, now we're on to compounds. Now we can show you our two jewel
Terrible
compound.
look.
Do you have a jug? No?
No, but I do have a...
That's all right.
Okay.
All right, compounds are going to be when you have 2 or more types of atoms bonded together.
So they're different types.
Yeah, different. Molecules would be like
Two the same.
hydrogens, 2 hydrogens stuck together. compounds would be like 2 hydrogens and 1 oxygen, which is H2O, which is
water.
Water. Here's a picture of water right here.
I had a little molecule like that floating around. I don't know. I think a
Floating
child
around.
stole it.
Alright, so notice we have H2O, this would be a hydrogen, this would be oxygen, and this would be another hydrogen. Okay?
Oh, and I have this right here. Ready? Watch.
She's got a little bit of a cold. This is called the molecular formula when you write H2O. It just tells you what compound's in there. It doesn't show you like the shape like this guy does. It just says, hey, you got 2 hydrogens and 1 oxygen. Okay? We call this one the structural formula. It shows how they're bonded to each other. It shows the structure. And then the last one we have is the ball and stick model, which you can actually do in class. We have kits for that. Okay, and it's literally balls and sticks that you put together to symbolize bonds and atoms.
I have those.
It gives you a 3D shape ID. Yeah.
Pretty cool.
Pretty cool. All right, the last thing we have is mixtures. Oh, this is for money. Alloys are going to be solid mixtures.
I'm finding
Mixtures contain 2 or more pure substances
this is a mixture.
that are not chemically combined. Okay, they're just in there together. They're not bonded to each other. They always have the same ratios. Example would be like Kool-Aid. That's not chemically combined to each other. And gold.
So like sugar water, that'd be a mixture.
Sugar water would be a mixture. I put money on there. That's not a mixture, but an alloy is going to be a solid mixture. So like jewelry grade gold. It's not pure gold. It's 24 karat gold. It's pure gold. But gold itself is too soft to use in jewelry. Preferably, you'd use like 14 karat gold or even 10 karat gold, which has less gold in it. More copper and nickel mixed in with that. What are you doing over here?
I'm having a heck of a day, right? Okay, next guy.
Next guy.
Oh, I got that one. Which one?
All right, there's homogeneous mixture. We can do that first. All right. A homogeneous mixture is going to be pure substances that are mixed. They're not going to be uniformly distributed. Or excuse me, they are. Sorry, they're not chemically bonded to each other, but they appear to be one substance, but they're not bonded. Okay. The example we have is iced tea. When you have iced tea, you have water, and then you have the iced tea particles. Gold jewelry is another type of homogeneous mixture. It looks like it's chemically bonded, but it's not. It's uniformly distributed throughout. You don't have areas that are yellower or silvery looking. Stainless steel, black coffee, and gasoline all appear uniform throughout. It appears if you took a sample, it'd be the same every time.
Right.
Okay.
Heterogeneous. This guy, different size particles.
This one's easy to pick out. These guys, again, aren't bonded towards each other. They are not going to be evenly distributed out. Anytime you have to shake something like salad dressing or orange juice, that's considered a heterogeneous mixture because things settle out. Okay. The example they always use is Italian salad dressing, orange juice because it has that pulp in it. Chocolate chip cookies. If you took a bite of a chocolate chip cookie, would you always get the same number of chips?
No, but I would really like to have a lot of chocolate chips.
Yeah, but that doesn't always happen. Sometimes you get a bite with no chocolate chips in it, and it's still, a chocolate chip cookie.
Dang.
And a lot of times salad, they talk about salad as a heterogeneous mixture because you might have carrots or tomatoes. Every time you take a bite, cucumbers, it's not going to be the same. So here's a couple things. Miss Keisher, you can be my student for the day.
Okay.
Here's iced tea. Is this going to be a homogeneous or heterogeneous mixture?
Well, I'm going to go with homogeneous because if I took a sample from the top and a sample from the bottom of the tea, it'd still be the same amount.
You are correct.
Same composition.
Yes. Italian salad dressing. Zesty Italian, by the way.
Well, I'm going to go with hetero because you can see stuff floating in there.
Yeah, and it settles out too. It's gross.
Yeah, kind of get this layer.
A stainless steel toaster. Is that going to be homogeneous or heterogeneous?
I'm going to go with homogeneous because it's stainless steel.
It is an alloy or a solid mixture of metals. And it's uniform throughout. It's the same color all the way through. It's the same composition all the way through.
God, I wasn't quite sure where you were going with the toaster.
I
thought maybe you were going with toast, and then never mind.
Then that's something completely different. Oh, we got a fly. All right, salad.
That's Frederick the fly.
Frederick the fly.
He's been here for 2 weeks. Okay, salad. Oh, heterogeneous because you got the big tomatoes and then the lettuce is different size.
Yeah, not every bite is going to be the same. It's not going to be uniform throughout. What about something like gasoline?
Well, that's definitely homo because it's just like the iced tea, where if I take some gas off the top, composition is going to be the same at the bottom.
That is correct. Orange juice.
Hetero, pulpy. I do not drink it because of that nasty stuff.
Yeah, it does settle out. Whether you get pulp free or not, there is a little bit of settling that is going on, so that's going to be a heterogeneous mixture. This is a gold wedding band. Gold. We'll say 14 karat gold.
So it's an alloy.
It's a solid mixture. Okay.
So that would be homogeneous.
Homo, because look, it's gold. It's the same color throughout. It's going to have the same composition throughout. Okay. And then your favorite.
Yes.
Chocolate chip cookies.
Now, if it was a good cookie, it would be heterogeneous because look,
Yeah, right.
you got multiple chips on the top, not as many on the bottom.
Yeah, then you had to factor in bite size and stuff like that. So that would never ever really work.
I would take a much bigger bite than you.
So this would be considered a
Heterogeneous.
Okay. So just basically, if you take a sample twice, is it going to be the same? That's what you need to ask yourself, right?
Yep.
Okay. The last one we have is mixtures versus compounds. First one says compounds are chemically joined together. Mixtures are just physically mixed together. Okay.
Come on, Frederick, leave us alone.
This is annoying. Just remember that if there's a reaction that happens, that means they're chemically joined together. It's a compound. Mixtures are just mixed together.
So, like when you take your dressing and you just shake it.
Yeah, you're just mixing it up. You're not making a chemical reaction.
You're not making the Italian become dressing.
Mixtures tend to behave like their components. Compounds act differently. So if you have salad dressing, you can still see that oil acts like oil in the water. They're going to separate out. Compounds, when they chemically form together, they're going to start acting like a different. Yeah.
So different chemical properties.
Yeah. And then mixtures can vary in proportions. Like we said, the chocolate chip cookie, if you take a bite, you might get 2 chocolate chips, you might get none, you might get 5. It's going to vary in the proportions that you get those. And then compounds are always going to have definite ratios. So like you would take a drink of iced tea, mind you, no sugar in it or anything like that. Just regular iced tea, it's going to be the same throughout.
Got it.
Okay, does that make sense?
It makes perfect sense.
All right, so just to recap really quick, we have pure substances. There's 2 kinds of those. There's elements, and then there's compounds. And elements, we have 110 of them. Compounds are 2 or more atoms bonded together.
Like water or
Like water.
H2O.
No, not
Same
yet.
thing.
And then we also talked about diatomics. There's 7 of them on the periodic table. You have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. That's 7 with the hydrogen. And then we talked about mixtures, heterogeneous, homogeneous. Heterogeneous means
Chocolate chip cookies.
chocolate chip cookies. They're different, can be separated. Homogeneous is going to be uniform throughout. Cool?
Got it.
All right, we'll see you in class.
Nice job. Peace out, friends.